Now we're going to round out our tutorial on Jupyter Lab in Python and pyplot using Python, of course, by looking at the stock market returns we've already looked at. And so this was the CSV that we ended up generating last time, right? We had basically years and returns for the S&P 500 that we calculated, the NASDAQ, the Dow Jones, and then we had like bin data and histograms and all these sorts of things that we had to calculate in order to display that data. We don't want all this, but that's okay because when we import, we can just say what rows or what columns we're interested in, right? So basically, I want the S&P 500 returns, the NASDAQ return, and the Dow return. And if I think about what's going on in these columns, what I see is that this is column 0 from the perspective of Python, column 1, 2, 3, and 4. So I want column 0, 4. Here's 5, 6, 7. So I want columns 1, 4, and 7. And so I've set that up already, just like we did last time. We have our CSV library. I'm getting prepared to make some plots, so I put it up here to begin with. And then I have this open as a CSV file, the stock market returns that I've already put in, and CSV read is going to be the red file. And now I have 3 arrays. I have what's going to hold the returns for the S&P, the Dow, and the NASDAQ. And we're doing the same trick where basically I'm going to say, like, let's not count the first row in this file here. So this is row 0 at the very top. We're going to skip it and just pull in data from following that. So as soon as we don't have row count as 0 where we start, right, and we start adding to this number as we go down the file, then we're going to start pulling things from spot index 1, 4, and 7, which is where we said we wanted our data to come from. And then we're going to try to plot this, and this plot, violin plot, is how we're going to try to represent this to begin with. And that's a plot we haven't yet made, but we saw when we talked about distributions. So we're going to see how easy this is to make it, but by the end of this, we'll also see how to make histograms. Now, there are 2 things I want to say about this. It's not going to work for 2 reasons yet. The first is that I actually set this up and then something happened and I went away and came back. And if you're online, you don't always have access to the Python interpreter, what they're calling the kernel. If you had downloaded this and used it, you'll never run into this problem. But here you will, and you'll see that it says no kernel in the top right. And so if I try to run this, nothing actually will happen because there's nothing around to interpret it. And so if that happens and you see no kernel, all I need to do is click on the kernel and say select Python 3. Then, where instead of no kernel, it says Python 3. And now I can try to run this. We're going to get an error. And the reason is that it says cannot convert string to float. Remember, this is the issue where there's like words around, but we're trying to turn it into a float instead. And that's happening somewhere in here. And it's saying it first encountered it in the NASDAQ side of things, which is row 4. We're skipping the first row, so it can't be there. So let's just scroll down and see if there's anything that looks like text. I don't see anything, but one thing you'll notice is that I ran out of values first in the NASDAQ return. And so actually, even though we like to think of this as empty, empty is a valid string in Python. And so it's imported a string value of nothing. And so one way around this is just in front of each one of these to include an if statement that checks to see if that's what's going on. So I could say if row 1 does not equal an empty string, so all it is quotation marks with nothing in there, colon, because it's a control statement. And then basically I can copy and paste this in, but change it to row 4. I need to indent after a control statement. and then last changes to 7. So now as it goes down, column by column, if it finds a number, it converts it to a float. And if it finds nothing, it just doesn't add it anymore. And that's fine. It'll just keep go row by row, but it'll just never add anything because this if statement is saying to add only when this is not an empty value. And so this will work. I will collect a number of things in the SP, which is our S&P 500, and then I'm going to just have it do a violin plot. See, and here's where I had a control statement and there wasn't something indented, so it's just telling me that there's an indentation error. All right, let's try it again. So it read our data and now I have a violin plot like we saw before. And of course I could have made a violin plot out of anything, like out of the NAS if I wanted to. Right, so there's a violin plot for it. But we'll explore that a little bit more. I do want to just take one moment and go back and see what these look like. So let's go print NAS. Now we're just going to see there's a series of values. And what would happen if I didn't have this control statement? This is back when it was throwing errors when I tried to do something, convert float to string. Let's get rid of this float for 1 second and see what happens. What does it see? It sees a bunch of empty points at the end. We didn't see this last time because all the data ended at the same time. So as soon as there's no more data being entered, we don't have to worry about this because it just stops reading the file. But in this case, because the data has unequal lengths, we have a bunch of these empty returned values along the way. All right, so that's what's going on. But anyway, we don't have to deal with this. We know how to get rid of that. So float, and then I'll indent this because we're going to delete this comment and use it like a control structure. And now we have just data back. Okay, as we said before, this data is already written. And so even if I do this, it's not around. I mean, it's still, the program knows about it. So I can do all my graphing down here. And so what we had started with was trying to show violin plots. So actually, let me just put this back up top so we know what we're looking at. Plot, violin, got it spelled right, or violin, plot, SP, and then plot show. Okay. We have this violin plot. It's not quite how I like to see them, and so I think the violin plots can maybe look better horizontal. So the way to address that is to say vert. That's saying that it's supposed to be vertical. The default for this is true with a capital T, and if we want it to be horizontal, we set it to false with a capital F. And now it will plot it horizontally. I also think they look better when it's just the shape and not so much like the lines that show the extrema and what's going on here in the middle. And so to get rid of that, we actually say show extrema, which are the high and low ends. And this was set to true by default, so we set it to false. And now this like bar and whisker in the middle will go away. Okay. So now we have a violin plot for our data that looks kind of how I like it to look. Wouldn't it be nice if we could have all three of them shown together? And in the past, we showed a way of doing this using adding axes and changing the different size of the axes. But another way that we'll see today is using subplots. And so what we want to do is use plot. We're going to put something in front of this in a second. Subplots. That's the function that we're going to use, and there's three of these, so let's call it 3, 1. And the first number is how many vertical, second number is how many horizontal. Okay, But we need to give this a variable name, and so fig works. And also, what subplot is doing is it's creating a series of axes for you automatically. And so we'll call those series of axes A. And so in thinking about what's going on here, fig equals the name of plot, A equals the axes we made. Okay, so now we go down and we can start adding plots. So just like before where we had created axes and then we said axis dot and what we wanted, we're going to do the same thing. It's going to be A dot violin plot SP. But the issue is I have 3 plots. So I need to say what the index is for this. And so let's put that in index 0. Then the next is to have the other plots. So index 0, index 1, and index 2. And then let's set this equal to NASDAQ and Dow. And then we can show this plot like this. And when I hit enter, or when I run this, now I have 3 plots stacked up on top of each other. They're facing the wrong way because I didn't keep this that we'd set up, but that's okay. I can just copy and paste this pretty easily into all 3 of these. And now it'll look like this, but with just the 3 stacked on top of each other. Great. One thing you'll notice is like the axes run into each other, and so we need to increase the spacing between the plots. And you could do this manually, but there's also a command that can be useful for us, which is to basically specify for that our entire figure, which remember we called fig. I'm going to say fig.tight layout. So I'm applying a tight layout to the whole figure. And what that means is that it's going to account for the fact that there can be text, and it's just going to make sure that the text fits. So now we have these 3 different plots. And you can see, like, when I look at this, it goes here, and then like the middle point of this is a little bit to the left of that. So let's say I wanted to reorder these somehow, then I could just change that to 2 and that to 1. And now they'll have swap position. And we'll talk about this a little bit more. If I don't want to get confused, I can of course copy and paste this, or cut and paste this in so that it'll look exactly the same, but now they're in order of 0, 1, and 2. Okay, so what is missing here, of course, are things like I don't know what X and Y are, I don't know what each thing is plotting, and so different ways of doing this are, let's focus on A0 for a second. We'll fill that one out before we move on. So A0, again, I'm saying that I want to talk about axis, the axes that are in the 0th index of this subplot grid that I have set up. And there I want to set the X label as, let's call this fractional returns. This is a string, so I need to put it between quotation marks. Actually, I can use either single or double quotation marks as long as they're the same. I know we've always used double quotation marks so far, and you can keep doing that, but you can also use single ones if you want. That's totally fine. And so set. I spelled set wrong. Set X label. All right. A0, set X label, fractional returns. I shouldn't need double quotation marks. Let's just double check. Something is wrong with the kernel. Okay, that's the problem. Something is wrong with the kernel. And so, trigger to flush cache, right then, cell, interrupt. Okay, so let's see what happens here. There, it's back. And figure A, set fractional returns. There we go. So there was just here, a communication error, I guess, with the server. That's quite all right. So what I did was I just said stop, interrupt the kernel, and then I reran things. And now what you can see is that fractional returns is labeled, and that's labeled for this first plot 0. And now we also learn that we count from top to bottom when we think about the indices. I can also give this a title if I wanted to. So how about 0 dot set title? And this I could call S and P500. And now if I run this, S&P 500 appears as the title. And so I can do the same sort of thing where I could set titles for these if I wanted to after the fact. So how about this one is really the Dow Jones. And so let's change that to refer to the correct indice. And then here I have the NASDAQ. And then that needs to also refer to the proper index. And now these should all have titles. And we run into this problem again, right? Where like these overlap. So now we'd really have to think about how to control the spacing between the plots. But I think actually a better thing for us to do in this particular case is just, since they all share the same name, let's just move this down into 2 and reload it, and now it should only appear at the bottom. And now things look kind of okay. Not perfect, but okay. Something else that's kind of strange about what's going on here is that they do look different, but are they really all that different? Like, look, this one peaks around just shy of 0.2. This one's around 0.1. This one's just shy of 0.2 again. So the issue is that the X doesn't span the same range. And so we need to also make sure that we have the X plots spanning the correct range. And so the right way to do this is to address the axis that we're interested in, and then say set X limit. And this actually is just a pair of numbers. So let's go -1 to 1 and see what happens. Maybe just xlim. Okay, so now you can see the x-axis goes from -1 to 1. And then I could just set these the same for everything. Again, I don't have to paste them underneath their respective plots. All that matters is that these indices are correct. But it can help in legibility. Let's plot this again. And now we see that they all fall pretty similar to each other. And maybe we should have actually had the NASDAQ and the Dow Jones switch places. So that's pretty simple. We decide, we should have changed this again, and 1, 1, 1. And we could have even decided to give like this its own name. It's fine though. So now they go in maybe decreasing order this way, and then this fractional we should assign to axis 2. And so it's on the bottom again. Great. Then looking at this, we could decide, well, maybe I could just go -7.5 to probably 0.9. So how about instead of writing this over and over and over again, I do something interesting. I say my max value that I want is 0.9, and the min value, so let's call it max x, and you can notice this is green, so it thinks it's something special. So let's give it a name that's not a special thing, -0.75. And so now I can just substitute in here max x for every one of our limits, and then min x for every one of the minimum positions. And now they will always be the same. And if I choose to change one, I can just do it up here. So I can say like, that actually looks pretty good, but maybe it would be nice if this was a bit wider, like -0.8. And so now I just change it at the top, and that carries through so that they're all the same all the way down. All right, the last thing I want to do is address the grid system just a touch more, all right? Because I have 3 things stacked on top of each other, but I could also make a grid where there's 3 more things if I wanted. And the way to do that is to add to these subplots a second column, right? The second number is how many things we have to the side. And so now each one of these, well, let me just hit return, and you'll see it throws a problem because it has 6 plots it's trying to draw, but I now need multiple indices here. So it's not just at point 0 anymore, it's at 0 of the first column. And so it's at 0, 0. And in fact, all of these, if I want them to be on the, I'm just going to copy and paste them in. If I want these to be on the left side, I'm going to put them in the first column, which again, by indices, means that it has index 0 in Python. And now when I hit plot, you'll see I've put them all in that first column. That means we have axes that we could choose to put things on the right. And why don't we just do that? So in the beginning, we had violin plots. And now let's make some histograms. And we'll see how easy this is here. And so we want those in the second column over to the right. So it'll be A, the first row, which is 0, but the second column, which is 1. So it's A, 0, 1, dot, hist, SP. So now I'm going to say I want a histogram of the S&P 500, and I want it in this top right position. And there it is. I've now made a histogram of the returns. And then I could do the same thing that I've done before, which is I could set the title if I wanted for this particular plot, and I just have to change this to be 1, and it should appear S&P 500. And we just do the same thing down. I'm not going to repeat this too much, but how about A, just to like show what's happening, 1, 1. So that's going to be the second row. That's this first 1 is the second row. And then the other row 1 is the second column. So right here. And that should be the NASDAQ. So we'll make this a histogram of the NAS. And then the last one is A. I want the third row, the second column, dot hist, and this is the Dow for Dow Jones. And then when I hit go, you'll see I have all those plots. And so now I've represented the same data with both violin plots and with histograms and generated them relatively easily. Again, the scales don't match up, right? Not a problem. Let's just go ahead and have that be the last thing that I want to show or include, is making these all correct. And so all that's different is that they are in the second column. And now these share the same x as even these, because it's all referring straight back to these variables we put up here. And now I've got this nice complex plot. I could continue to add in titles. I could continue to add in labels for the x. I could add in labels for the y, following the same procedures. But essentially, I'm just showing you how the grid system, which you've already seen in views, works when we're trying to do it in Python. And then also how to show a couple different styles of distributions, both violin plots and histograms. Violin plots we didn't even see in views, though it can be done in histograms, which we saw, but it was much more work than just typing hist and saying that's what I want. So there's the last sort of tutorial video we'll have on Python, and there'll be one more assignment where you just pick data of your own interest and try to make a plot out of it. And again, I'm just trying to show you basically what's under the hood in terms of how these programs typically have to read data and then try to represent them. So hopefully it's been interesting.